Hey class, in this video we're going to continue with our radical operations and look at addition and subtraction today. So I want you to start with those warm-ups because I think they're going to get you in the right mindset because simplifying radicals is just like combining like terms. So we're going to think of things with a radical just like combining like terms. So here with like terms, my x's would be like terms. So I could combine those. So 3x minus 5x is negative 2x. My y's are another pair of like terms. 4y minus 8y is a negative 4y. And then I've got that 7 that doesn't have another like term. This would be a simplified expression because none of these are like terms. With radicals, they have to have the same number underneath the radical to be considered like terms. So this root 7 and this root 7, those are like terms because they are matching radicals. So we're going to act just like this is like an x. So like 5x minus 3x, same exact idea. So 5 minus 3 is 2, and then I'm going to hang on to that square root. So that becomes 2 root 7. My 6's are another pair of like terms. So because they have the same radical, I can go ahead and add the coefficients, the numbers in front. So I've got 7 plus 8, which is a positive 15. So I get plus root 6. Since these square roots are not matching, those are not like terms, and I cannot simplify anymore. So that would be as far as I can go. Number 2, these all have square root of 3. So they are all like terms, meaning I can combine all of them. So I'm going to look at the numbers in front, the coefficients. 5 plus 10 is 15. Minus 6 is 9. 9 plus 15 is 24. So I get 24 root 3. Okay, number 3 here. So in this one, it appears that I don't have like terms and I can't combine them. But 8, I can break down. If I think about 8, I know it's made up of factors of 2 and 4. Well, 4 is a perfect square. The square root of 4 is 2. So I can change 8, the square root of 8, to be 2 root 2. Well, now, because it's root 2, it matches this term. So don't forget I had that 5 out front, so I'm going to change that to 5 times 2 root 2, and then I have got minus 3 root 2. So 5 times 2 is 10, so I've got 10 root 2 minus 3 root 2. Like terms, they both have matching radicals, so I can do 10 minus 3, which is 7. So 7 root 2 would be my simplified expression. Okay, so whenever you don't have like terms, you want to see, is there any square roots we can break down or simplify and end up with more like terms to combine? So again, in number 4, not like terms upon first look, but 45 is one that I could break down. This is 9 times 5, which 9 is a perfect square. The square root is 3, so I can pull out the 3 and leave that as 5. So now that it's a 5, it's like terms with this. So I've got negative 2 root 5 plus 3 root 5. Negative 2 plus 3 is 1 root 5, which typically, just like with x's, we don't usually write 1x, we just write x. Same thing with radicals. We don't usually write the 1 in front if there's not a coefficient. We just write square root of 5. All right. Number 5 first. Okay, so again, if there's not a number in front, it's kind of like there's a 1. So negative 1, 3, and 2. So here I've got a lot of big numbers going on. So I'm going to kind of work with one at a time. 20 is the square root of 4. And I still got that negative 1 out front. Square root of 4 times the square root of 5. Square root of 4, that's a perfect square. That's 2. So I can pull a 2 out front and the 5 stays underneath. All right, 80. So I've got this one. I'm not sure about a perfect square, so I'm going to go ahead and employ my factor tree. So 80, I can break into 8 times 10. Neither of those are perfect squares, so I can't pull those out front. I can break out 2 and 4. 10 I can break into 2 and 5. And I can go a little bit further with this 4. I can break it into 2 and 2. So I'm crossing out the ones that I broke down. So I got a pair of 2's here and a pair of 2's here. So I can pull 2 2's out front and a 5 underneath. So again, don't forget I got that -1 in front. And then I've got 2 pairs of 2's coming out front, so times 2 times 2, and then a 5 underneath. So right now I've got this expression and this expression. Now I've got square root of 5. Those are like terms. 3 root 7. 7 is not one I can break down without using a 1, and it's not a perfect square, so that one's going to stay. This one, 28, I can break into 7 times 4, and 4 is a perfect square, right? So I'm going to pull that 2 out front. So I already had a 2 out front, so I'm going to get another one with a 7 left underneath. So let's rewrite what I have. I've got a lot going on here. So I've got this one is what I broke square root of 20 down into. So I got -1 times 2 is -2 times the square root of 5. 2 times 2 is 4 times -1 is -4. So this is what I got from the second term, breaking it down. Third term, remember we couldn't do anything with that, so we left it. So plus 3 root 7. 28, we broke down into this guy, which 2 times 2 is 4. Okay, so now that I've reduced all of my radicals, I've simplified them as much as I can, now I can look for like terms. So I've got some square roots of 5, so -2 minus 4 is -6 root 5. These are both root 7, so I can combine 3 plus 4 to be +7 root 7. So there would be my simplified expression after both reducing all my radicals and then combining like terms. Last example, number 6. 48, break that down. And if I know that's a 3, maybe I want to try and see, is this divisible by 3? So that I know I have matching square roots or like terms. Which 48 is divisible by 3. 3 times 16 is 48. 16 is a perfect square. It breaks down to 4 and 4. So that 4 can come out front. 3 stays underneath the square root. And then I've got minus 4 root 3. Well, this is something minus itself, which anytime you subtract something from itself, you get 0. Okay, guys, thanks for watching.